Okay, so this is again more combining dynamics with energy. So we have a 50 kilogram crate being pushed up a ramp at 22 degrees. And the length of the ramp is 5 meters. So let's draw that picture. So 22 degrees. Here's our object. We're pushing it up the ramp. So we make that arrow parallel to the ramp surface. Force of friction is opposing it. So we have force of friction opposing it. Our applied force, force of gravity is downwards. Normal force is perpendicular to the surface. Okay, so we have our forces. Okay, so in order for us to push this crate up the ramp, we have to overcome both gravity, because we see gravity is pulling downwards, but we also have to overcome friction. So we need to find out what is the force of gravity in the direction of motion. We also need to find the force of friction in the direction of motion. So let's go ahead and solve for it. So we need to solve for it. So here's my block again. Force of gravity is downwards. So we remember how to draw our triangle from our dynamics unit. So force of gravity is there. And we see this is the force we're trying to find. That's Fgx. That says equal to Fg. That's our 22 degrees. Fg sine 22. And this is Fgy, which happens to be equal to our normal force, which is just equal to Fg cos 22 degrees. Okay, so we look at Fg, find Fgx first. That's equal to our 50.0 kilograms times gravity multiplied by sine 22 degrees. Plugging into our calculator, we get 183.6 newtons. Force of friction is equal to the coefficient of friction multiplied by the normal force. But our normal force is equal to Fgy. So that's just equal to Fgy, which is just equal to, next just put down here, it's equal to the coefficient, which is 0.3. Our force of gravity is 50.0 kilograms multiplied by gravity times cos 22 degrees. So we end up with a value of 136.3 newtons. Now for us to push this thing up at a constant rate, we get Fa is equal to Fgx plus force of friction for a constant rate. What that means is if I want, I can expend more energy. We'll get the block up there faster. It's going to accelerate as it's going upwards. But right now we're just trying to find that minimum quantity needed. So basically what's going to happen is it's going to add up those two values. We need at least 319.9 newtons of force to push this block upwards. So work applied. So how much force must we exert? Fa times d. That's just 319.9 newtons. Traveling 5.0 meters. We need 1,600 joules of energy to get that block up the ramp.